In this video, we are going to investigate two different linear relationships. The relationship of the SUV for the amount of gasoline used compared to number of kilometers driven, as well as the minivan's gasoline remaining versus kilometers driven. So both of these relationships are using the same variable, distance and gasoline remaining, and distance and gasoline remaining. So while I read this, the environmental project, it says, for a project on the environment, you've decided to gather data on two similar types of vehicles, an SUV and a minivan. Compare the distance that the vehicles can travel on a full tank of gasoline. For each kilometer a vehicle is driven, the gasoline is used at the given rate. So we are also given the equation of the line that represent the amount of gas remaining for both the SUV and the minivan, depending on the kilometers driven. So I'm just going to write the SUV's equation up above. So G is equal to 80 minus 0.20D. So I know, because it is a line, that it's something like y equals mx plus b. So the value of negative 0.02D, that tells me, because it's attached to the variable, that's my rate of change. That means 80 is actually my starting value. So when I have a distance of 0, my starting value is 80. Also, I could calculate that using the relationship. Okay, so if I use this relationship, the first D was equal to 0. So I want to calculate G, so that's 80 minus 0.20 times 0. So if I'm going to evaluate that, this is multiplication, and over here we have subtraction. So bed mass is used to find a value or to evaluate. So I should be using bed mass. Inside the bracket there's nothing to change. There's no exponents, there's no division, but I do have multiplication. So I will multiply 0.02 by 0. So 80 hasn't changed. I'm going to write subtract underneath, and 0 times 0.02 just gives me 0. Now I know that I can subtract 0 from 80, so it turns out that we in fact have the amount of gas remaining after 0 kilometers is 80. And that's where we were here when we have 80. I will also use a distance of 100, and I'll do that on the separate page. And then after that, I'm going to use my first differences to fill out my table. Okay, so if distance is 100, then G would be 80 minus 0.20 times 100. Again, I'm going to multiply. So I'm going to do this operation before I subtract. So I'll have 80 minus 100 times 0.2 is 20. So 80 minus 20 is 60. So after 100 kilometers, I will have 60 liters remaining in the tank. Okay, so I can put 60 liters remaining in the tank. The first difference is 60 minus 80, it's negative 20. So since, as Marie pointed out yesterday, since I am increasing by the same amount all the time, I can use the same first difference. So this would be minus 20, and minus 20. So 60 minus 20 would give me 40. 40 minus 20 would give me 20, and 20 minus 20 would give me 0. So I'd have 0 liters remaining after 400 liters. I can use the equation given for the minivan in the same way. So I will have, for 0 distance, 65 kilometers, or 65 liters left. And I will try for 100 kilometers, 200 kilometers, 300 kilometers, and 400 kilometers. So we will do the calculation just for 100 kilometers. And let's do a new page. So if distance is 100, then G will be 65 minus 0.15 times 100 this time. Again, I have the option of multiplication here or subtraction here. I will multiply first because of bed mass. So I'm going to subtract the value of 0.5 times 100. That's just 15. 65 minus 15, we're at 50. So when I have traveled 100 kilometers, I have 50 liters of gas left, and I'll fill that into my chart. 50 minus 65 is negative 15. So apparently every time I change by 100 kilometers, I will go down by 15 liters of gas. So I'll subtract here, I get 35, down 15 again, and down 15 again. This will give me 20, and this will give me 5 liters remaining. All right, then I need to graph both of these relationships on the same set of axes. So I will need to go up to the distance of 400. So from 0 up to 400. And I will need to have enough space for my gas, so this is gas remaining, to go up to 80. So I think I have 10 spaces here, so we'll go every other one can be 10. 10, 20, 30, 40, 50, 60, 70, 80. And here I will count by, let's see, what do I have to go up to? 400 divided by 20 gives me 50, so I need to count by 50. No, that's bad math. 20. So each line is 20. So we have 20, 40, 60, 80, 100. That's not going to do. I must only have 10 spaces. 10, so I count by 40s. So we have 40, 80, 120, 160, etc. So that means 100 is right here, and 60, and there's 200, and we'll continue. So for a distance of 0, the first point is supposed to be 0, 80. So I'll use green to talk about the SUV. So 0 and 80, that's my starting point. At 100, I'm supposed to have 60 kilometers remaining. Okay, and I know it's a line, so I can actually just use my linear relationship line tool to graph the rest of this. So from here to there and onwards until we hit the bottom. And for the minivan, I'll use red. So I start at 65, and then I go down to 50 after 100. So we have 2 points here. And after 200, I should be at 35. So I've got enough information to draw this line. And we'll use this one. And what we see is, there's 100. Oh, I'm slightly off. Okay, we seem to be on the right point. Okay, so we actually find out here that even though the SUV started with more gas, the minivan and the SUV will have the same amount of gas at this point right here. Okay, continuous. How did we know that the data was continuous? Well, I could travel a distance of 53.2 kilometers and have a certain amount of gas remaining. There's portion values allowed. The independent variable here is the one I label on the x-axis, so it's distance, and the dependent value is the amount of gas that remains. Okay, on the next page then, I have to identify for the SUV what the rate of change is. So the equation for the SUV was G equals 80 minus 0.20D. So the rate of change is 0.20, and that's going to tell me that it's negative, goes down 2 liters per kilometer, sorry, 0.2 liters per kilometer driven. The initial value was 80, and that tells me that I had 80 liters of gas to start. Okay, so if we examine the differences, it says how do they relate to the graph and the equation? So the difference is we were getting negative 20 and the change in distance was 100. So if you have negative 20 divided by 100, then you get the value of calculating 0.20. So look at that. The rate of change has come from the change in the table. All right, so if we compare the graphs, how are the graphs the same? They are both negative rates of change. They are different because they have different initial values as well as different rates of change. For the minivan, what does the ordered pair 100, 50 mean? So I've just written that 100 kilometers driven leaves 50 liters of gas remaining. If the SUV is driven 250 kilometers, how much gas is left? So that's the last question, and we're going to need to use our equation for calculation here. So for the SUV, gas is calculated from 80 minus 0.20D, and when they say 250 kilometers, then I'm going to put that in for D. This is a distance. So the gas is 80 minus 0.2 times 250. And just like we worked on the table, we can figure out how much gas there is remaining. On the next page, it says if the minivan has 35 liters of gasoline, so that was this equation, how far has it been driven? So since it's in liters, I'm going to put 35 into my equation for G and solve. So this is solve for D. This is where I need to do bed mass backwards. And when I do that, or SAM-DEB, then I will wind up with a value of D equals, so the distance equals 200. So D is equal to 200 if there's 35 liters of gas remaining. So that's the kind of solving equations we have done recently. Number 9, a vehicle has a full tank of gas and is driven 250 kilometers. Find the amount of gasoline remaining in the SUV and write the answers in the ordered pair. Well, we actually just figured out, oh, no we didn't, so we can work that one out. Again, we know the distance, and we're talking about the SUV, so I'm going to write G equals 80 minus 0.20D, and I'm going to fill in the distance of 250. For the minivan, G is equal to 65 minus 0.15D, and replace D with 250. The values that we have left are 30 liters of gasoline in the SUV and 27.5 liters of gas in the minivan, and we will write them as the ordered pair, which we would find on our graph. Oops, that should be 30. Which vehicle has more gasoline remaining? So comparing the two above, there's 30 liters in the SUV and 27.5 in the minivan. So in other words, the SUV has more, and the difference is 30 minus 27.5, or 2.5 liters more. So, explain what this problem tells you about the two vehicles. Because the line is decreasing, we know that the gas goes down. We also know that they have different rates, and what we can see from the graph is there's one point where they have the same amount of gas remaining. The point of intersection. With the same gas remaining. And by inspecting the graph, we actually see that after 300 kilometers, they both have the same amount of gas. Gas left is the same. Okay, so you will be given a couple of other investigations and you need to relate the graphs, the rates of change, and what they mean.